Hyperbolic trig problem set number 3, we finally get to do actual calculus. I thought about giving you proofs, and then I thought, this is calculus. We're finding derivatives in the first semester. Let's stick to finding derivatives. Proofs are for pure mathematicians, and you're probably going into engineering where you just need to crush this. So let's start with the first one. F of x equals hyperbolic tangent of 1 plus e to the 2x. Well, from the explainer video, I'm sure you remember that the derivative of hyperbolic tangent is 1 minus hyperbolic tangent squared. And you might have learned it as hyperbolic secant squared because it's more condensed, but I hate not using sine, cosine, and tangent. I always find it to be confusing and difficult, so I'm using this. And then what have we got? Well, it's going to be just a basic chain rule. Here's our outside function, inside function, more inside function. So the derivative of this, f prime, is going to be 1 minus hyperbolic tangent squared of 1 plus e to the 2x. Like that. Chain rule. What's the derivative of e to the 2x? Well, it's e to the 2x. It's itself. But then chain rule times 2. So our answer for this is just going to be 2e to the 2x times 1 minus hyperbolic tangent squared of 1 plus e to the 2x. Now, doesn't that look scarier than it was? Because it looks cool. Come on, look at this and tell me that's not cool. But it's easy to solve, as long as you remember the explainer video that showed you how to find the derivative of tangent. And we're going to need it in a minute probably, so let's have a look at the next one. The next one says, what's the derivative of hyperbolic cosine of natural log of x? Well, this is something we can do immediately. I don't think we even need to write it out. Derivative, outside function, inside function, right? We talked about the derivative of hyperbolic cosine. That's just hyperbolic sine. There's no negatives and positives for those. It's just the hyperbolic cosine's derivative is sine, and sine hyperbolic cosine's the cosine one, and so forth. So it'll be the derivative of the outside with the original input times the derivative of the inside times the derivative of that inside, but that's just 1. So I think our actual answer is going to be hyperbolic sine of natural log of x over x. And again, this looks so cool. Looks like a scary function. Who knows what that does? But I know this. That's the derivative. And when we're doing functions, that's probably all we're going to need to figure out. Now the next one looks like it actually might be kind of hard. Hyperbolic cotangent. I can understand why you would need to express that, because there's no real easier way to say cosine over sine. But do we know the derivative of cotangent hyperbolic? I do not off the top of my head, so I'm going to find that real fast. And I think the way to do it is to break it into cosine hyperbolic over sine hyperbolic. It should be fast because they're each other's derivative, and that'll be u prime v minus v prime u over v squared. What rule is that? It's the quotient rule, because we have a function divided by a function here. It actually isn't that complex. So u prime, well, the derivative of hyperbolic cosine is hyperbolic sine. I don't know why I wrote squared. I guess because I was looking at this one and I could just feel it. V prime, hyperbolic cosine, it's the derivative of hyperbolic sine, times the original upper. And that's all going to be divided by hyperbolic sine squared. So what do we get here? We get hyperbolic sine squared minus hyperbolic cosine squared over hyperbolic sine squared. So I feel like that's 1 minus hyperbolic cotangent squared. It's exactly like tangent was. Exactly like tangent was. That's weird. That's weird. And as a consequence, you could probably write it as like cosecant hyperbolic squared, just like the other one was secant hyperbolic squared, but these are stupid. This is the way to go. So we'll do it that way. I'll just keep that in mind real quick. 1 minus hyperbolic cotangent squared. I can remember that. And what we have here is a product rule, right? U prime v plus v prime u. U. That's what y prime is going to be. So what are our u's and v's? U is x, so du, or u prime, is 1. And v is hyperbolic cotangent of this coolness, 1 plus x squared. V prime, 1 minus hyperbolic cotangent squared of the original. Chain rule. Don't forget to put parentheses around the whole thing, 2x, like so. I think that's right. I think that is right. I was kind of thinking about bringing the 2 out there, but I don't actually believe that's the case because it's not a function, and not another chain rule function thing. It's just 2x is the derivative. So we can work it out. U prime is 1, so that's easy. So the first term is just going to be the original. I like that. Plus v prime, that's this coolness here, 2x, 1 minus hyperbolic cotangent squared of 1 plus x squared. And this whole thing is going to be multiplied by x. So I guess we could just make it 2x squared. And that's going to be the derivative for this one. Let's see, I like keeping it all in cotangent. And that way, if we need to take y double prime, well, you're going to be able to do this again because you have it here already. You could put it right here and then add whatever this nightmare's derivative would be next to it. So you can continue chaining the derivative down. I wouldn't recommend going down that rabbit hole very far, but nonetheless, how cool does this look? Let's call the first 3 questions the first video. I'll add a couple and we'll do another video.